My name is Olli Seppänen. I'm from Aalto University, Finland, and Associate Professor of Operations Management in Construction. My topic today is that why do we need a real-time picture of construction site? I think the key reason why we need real-time situation picture is that we have a huge productivity problem in construction industry. McKinsey did a study in 2017, and many national agencies have shown similar images that construction's value added per hour time dollars have stayed the same or declined, while all the other industries have increased because they have embraced lean manufacturing and they have embraced digitalization. Construction is trailing in these areas. So we have achieved very low productivity growth since 1995. Productivity is quite important also for the sustainability goals of United Nations, and this is tied to decent work and economic growth, industry innovation and infrastructure, and responsible consumption and production. Solving productivity problem of construction is a big deal because construction is a big part of national domestic product, gross domestic product of each country. And when we think about productivity problem, we need to go on worker level. So why is the worker not productive? And current digital approaches are not that well targeting these problems. If we want to figure out if the worker is productively working on task X, location Y, and time Z, they need to know which locations are ready for them and why are locations not ready. What actually should they do? Where are the tools and materials? And how and when the work should be done. This information is not very easily digitally available today. And these are some images that Fira, a Finnish construction company, has taken from their sites. And they kind of illustrate the problem. A lot of communication on site is happening by using graffiti today. We have done some studies, including helmet camera studies, where we put helmet camera for a period of a week or 2 weeks, and then analyze how much of the work is directly value adding. Try to categorize the work into different segments or buckets. And just 20 or 30%, 20 to 30% of the work is actually working. So this is data that you see here are related to carpenters. The actual work time of 2 carpenters over a period of 1 week was 21%. They were spending almost as much time in movement, so just moving from one location to the next, or working with materials, or doing measurements. All of these 3 big segments that are not actual work-related time could be solved with real-time situation picture, real-time construction monitoring. We have done the same research with many different methods, for example, indoor positioning, direct observation of people, so-called time and motion studies, and we have analyzed carpenters, plumbers, and electricians, and with all the trades, with all the methods, we get very low value-adding percentage. So this reduction of waste is key in solving the productivity problem, because with one intervention, for example, targeting at better logistics, you can increase productivity of a lot of different work types, while previously productivity improvement has been tailored to a single work type, for example, by looking at how to improve productivity of masons or concrete element work. But here we can get productivity improvements for multiple tasks with one improvement. And real-time situation picture could have a big role to play in this problem. But first of all, it's quite difficult to see waste in construction, so we need some kind of real-time KPIs that allow waste reduction and continuous improvement. And so far, digital tools have not been able to give this kind of real-time KPIs, but the new real-time tools are able to actually detect and measure waste. One of the technologies that is quite important in this respect is real-time positioning of resources, where you have some kind of gateways in work locations, and then workers and materials are attached with beacons, and every foreman and superintendent or other people can see where people are. And this data can also be analyzed automatically, and you can see how much people are moving and how much they are staying in the work location, and are they in the right work location at all times. So here we can calculate KPIs like how much of the time workers are actually staying in work locations, and are they just doing short visits, which indicates that there's some problem, or are they staying there for 10 minutes or longer at one time, which indicates that they may be working productively. And here are some example results of a sample project. 52% of the time workers were in work locations, just visiting work locations. But if they have to stay in one location before moving elsewhere 5 minutes or longer, the percentage drops to 37% or 34%. So this kind of KPI could be calculated for the whole site at all times by using indoor positioning techniques. If we integrate schedule information, then you can also evaluate whether the workers are in the correct work location, and then give alerts that how many of construction workers are in the right work location today. This normally doesn't indicate that the workers are not willing to follow the plan, but there's some problem in those areas where they are planned to work. And our results that we have done so far for just as a proof of concept for a few workers, the blue bar shows how much of the time they are in the right location, and the red bar how much they are in any work location. And around half the time they are actually spending in the correct work location in a few projects that we have observed. Now we are doing this with much bigger scale on another research project. But it looks like half the time people are where they are supposed to be according to plan, and there are various problems which prevent them from doing work in the assigned location. And the KPIs based on this uninterrupted presence or presence index, which is the uninterrupted presence divided by actual duration. And we have measured on average 34.5% over several projects. So this kind of indicates how much of the actual time you need people to be present. Another is presence to plan, which is divided by planned duration, and the measured average has been 33.8%. The conclusion from these percentages is that at the moment, in order to achieve schedule objectives and finish the project on time, the workers have to be present just 1/3 of their work time, removing breaks in order to achieve schedule objectives. So there's 2/3 of the schedule time is just empty. No one is there. So there are significant opportunities for improvement if you can measure this and then take actions to improve. That's why real-time production site is important. Of course, in order to actually fix this problem, this is just measuring how well you are doing, but to fix this problem, you need situational awareness, basically know what's going on in all locations, and for that, reality capture technologies can be useful. So you can have a lot of different ways how visual data can be captured from projects. Laser scanning is already being used in more advanced projects on daily basis to do point clouds, which can be compared with BIM models to evaluate progress. Boston Dynamics has a spot robot, which can be used to automate this data collection. We have done some initial tests with that. It's a little bit heavy robot, so I would assume that some lighter version just for data capture will emerge in the coming years. And I know that there are some technologies being tested. And of course, outside, it's safe to fly with the drone and take these point clouds and take cameras. In addition, now it's becoming quite common that project personnel are walking the site with helmet cameras, 360 helmet cameras, and there's a record of what's going on in each location. There are technologies in Finland and in the United States for that. And I think also Israeli companies, and I assume many more, that are able to take 360 videos and use them during construction process. And this allows BIM models to be automatically updated. I think there are already some solutions which allow this automatic updating, and more are coming. All times this is developing quite fast. And of course, if you have images from every day and you can separate them by element, then you can also use augmented reality techniques to show kind of the life cycle of each construction element. This progress updating can be automatic, so it's possible to use computer vision techniques to analyze these images and then evaluate whether elements have been completed or not. And also automated quality inspection could become feasible in the next few years. And already some good proof of concepts exist. And actually at Aalto University, we have also done proof of concept implementations. But this technology is now being used. Automation is still being developed. So at the moment, it's quite manual process still for most part, and people are just using these 360 videos and going virtually to see the locations, maybe making observations based on these locations. But this BIM model automatic updating and automatic progress monitoring is not happening in big scale yet, but I would say that in the next 5 years it will become standard practice. From here, it's still a long way to real-time situation picture, because in addition to progress and knowing where people are, different stakeholders have different needs. So we really need to combine information from all stakeholders to have a really real-time construction site. We need to link the designs. We need to link the owner and change management. General contractors need information about their supply chain, availability of resources, and so on. The blue-collar worker needs easy access to right information at the right time in order to have less wasted time. And all the subcontractors need to understand all the aspects of related work and be able to integrate plans with others in order to get increased productivity. The suppliers have long been ignored in the site digitalization, but now with real-time construction site, it should be possible for suppliers also to see how their products are being used and evaluate when their products will be needed on site. And that will enable new business models and better service for many suppliers as well. So if we get this kind of real-time situation picture, real-time construction site, all the actors will be able to improve their services and project outcomes will improve. In order to solve the productivity problem, it's not enough to have point solutions for data collection and analysis. So yes, it's nice to have some solution that allows you to look at 360 images or point clouds, but as isolated system, it's not enough. Somehow we need to get all these real-time information flows and link them to workflows of all stakeholders. So what decisions are we making? How can we get information from this real-time data? And if possible, automatically link it to our workflows. for that, we need to standardize the data models. We have standardized BIM models to some extent with the IFCs, industry foundation classes, but we need something similar for workflows. And we have taken the first step in the digitalizing construction workflows project and actually published an ontology that could be used for future development. Then we have too much raw data coming from all these systems. We need AI systems. Traditional deep learning based AI is not enough because it requires huge amount of training data. And it typically is a black box system. So we need the next generation neurosymbolic AI, which kind of combines context information to deep learning techniques. So could utilize, for example, ontologies in order to make better decisions about what the image is about. And digital twin is now a hot word. We should expand the concept of digital twin from just the product to also processes. So we have some planned theoretical process, and then we have the actual process. And the actual process should be constantly compared with the planned process. For example, like this, we have some actual process that is being followed, some actual product that is being built. We can sense automatically what is happening in the process and what is happening to the product. And then we have digital twin that we can use for optimization and decision making, and ultimately automatic coordination. I think here also first steps have been taken. The maintenance digital twin is already quite developed, but during construction, there are still limited ways how to sense construction process and how to integrate all that together to have a real process digital twin. So I would say we have sensing starting to be quite used in many projects. The process digital twin is starting, and then we are just doing the first proof of concepts on what we would really do with that process digital twin. And there are also some proof of concepts for automatic coordination of workers, but there we are in the early stages. But some ideas are presented today in other presentations. Key is to have all data linked and flow, including design data, product data, production data, all this automatically collected data going to as-built data. So we need distributed common workflow data, which is then used by multi-platform tools and services. We need open data sharing, ontologies, and standards, and then also have some kind of collaborative data creation practices that respect data ownership. That's my idea of how real-time construction site will help solve the productivity problem. And I hope there will be some questions at the end of these presentations. Thank you.